Good morning, students. After the completion of the structure of atom, we take periodic classification of elements. So write down what is periodic classification of elements. Now write down. To have systematic study of elements in a tabular form is called periodic classification of elements. So your topic is periodic classification of elements, that is the systematic study of elements. So to have systematic study of elements, many attempts were made to explain the periodic table. Newland's law of octave, Dobriner's triad law. In Dobriner's triad law, Dobriner tried to explain the series of the three elements in which the atomic mass of the middle element is the average atomic mass of first and the last. And the Newland's law of octave is the properties of first element must be resembled with the properties of the eighth element, like musical note sargam. So all these laws, all these opinion were rejected because of not fit for every kind of element. So whenever many more elements were discovered, it was outrightly rejected. Two milestones are there. One is Mendeleev's periodic table. Russian chemist Mendeleev explained periodic classification of element in that way. Write down Mendeleev's periodic table. The physical and chemical properties of elements are the periodic functions of their atomic mass. Periodic functions means repetition of properties after certain regular interval. Periodic function means repetition of certain properties after regular interval. So, a structure of the periodic table according to Mendeleev is the periods and what is that? Groups. Periods, you know it very well. Horizontal rows 1 to 7 are the periods, and groups are the what columns? Vertical columns. Groups are 18. So each period starts from the alkali metals and completed at the inert gas. Okay, it's all right. So the period, first period, second, third, fourth, fifth, sixth and seventh. Hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. So it starts with the alkali and ended at the inert gases. So far as modern is also in that way. So neon, argon, krypton, xenon and radon. So this is the incomplete, no inert gas is discovered yet. So helium, neon, argon, krypton, xenon and radon. And this side, first period from hydrogen, second lithium, sodium, potassium, rubidium, cesium and francium. So in that way, horizontal rows or from LHS to RHS of the periodic table. Now groups. Vertical columns of the elements, that is he divided each group in A and B except 0 and group 8. That means from 1st to 7th Mendeleev divided into A and B. So that means 7 into 2, 14, and the total groups are 16, but vertical columns are 18, because group 8 contains 9 elements: iron, cobalt, nickel, Ru, Rh, palladium, osmium, iridium and platinum. And he did not classify these elements in separate group because he was of the opinion that they are so closely related to each other, it was difficult to separate them out. Therefore, one was the zero group. He already predicted the position of the inert gas as well as the group 8 of the periodic table. So, the merits of the Mendeleev periodic table was, you can see, merits of Mendeleev periodic table. First time systematic study of about 63 elements were explained properly. Second, he corrected the atomic mass of beryllium from 13 to 9. That is the right place: lithium, beryllium and boron. Initially it was 13. This is the 7, 9 and 11 now. So, because of initially it was equivalent mass into valency. So, valency was taken as 3 and that was equivalent mass 4.5. So, it becomes 13.5. If it is 13.5, then it is supposed to be placed in between carbon and nitrogen. So, in between two non-metals, metals should not be adjusted. Therefore, he rectified or amended the equivalent mass into valency 2 is still it is correct. Valency of beryllium is 2 and it got 9. So, it is very fit here. In between lithium and boron, beryllium is well placed. Okay. Then third is the merit is he left some blank places for what element? Future elements. And then fourth is you can say he predicted the properties of Eka aluminum and Eka silicon. Eka aluminum is the gallium today and Eka silicon is the germanium today. Whatever the properties predicted by the Mendeleev is still correct. So he has vision to explain all these. So after all, come for the drawbacks of the Mendeleev periodic table. Most of you might be knowing the drawbacks. Position of hydrogen is not properly justified. Drawbacks. First, position of hydrogen is not correct. Second, anomalous position of argon and potassium, cobalt and nickel. 58.9, 58.7, 39.9 and 39.1. So it should be placed like this and this. So atomic mass of more atomic mass placed before the less atomic mass. So it is the drawback. Third is the no place for isotopes. For example, hydrogen has 3 isotopes. Each has different atomic mass. So they are supposed to be placed in the different groups. Here Mendeleev is failed to explain. And then see, copper and mercury are chemically close to each other but placed in different group. Copper is in first B and mercury is in the second B. Similarly here, that is the heavier metals like copper, Ag, Au having very high melting point and boiling point and are used in making alloys or the quinase metals are placed with sodium, potassium, etc., and they are very soft and light metal having low melting point and boiling point in that way. And then fifth, sixth point is the position of lanthanoids and actinoids are not justified. So they are taken from the main body of the periodic table. In that way, Mendeleev periodic table also suffering from certain shortcomings. Right. Now to overcome such difficulties, dear students, the next was the Moseley's and Bohr's periodic table. You know it, this is the modern periodic table. So far as the modern periodic table is concerned, you can see here modern periodic table, that is the, you can see, Moseley and Bohr, 1913. The physical and chemical properties of elements are the periodic functions of their atomic number. So atomic number is the basis of periodic table because it explains the certain properties based on the valence electron. If you know the atomic number, then you can have the electronic configuration by making the above principle, and then group number decides the similarity in their properties. Like sodium, potassium, lithium, rubidium, cesium, they all have one electron. It is because of the atomic number. Atomic number helps in writing the electronic configuration, which helps to explain the similarities in their properties. So this credit goes to the atomic number already explained by the, you can see, Moseley's periodic table. So position of elements is like this, all those 7 periods and the 18 vertical columns, no doubt. The first period, second, third, fourth, fifth, sixth and seventh. You remember of principle 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, 5d10, 6p6, 7s2, 5f14, 6d10, 7p6. So here 2 elements are there, 6 plus 2, 8. This is the 8, 18, and this is the 18, and then 32, and it is the again 32. But this time we have only 19 elements. So total I think 105 elements. It is although 32 I have mentioned, but 19 elements are discovered so far as 105 is concerned. So it is very short period. It is very short period. This is called as what period? Short period. This is called as long period, and this is called as very long period. So 2, 18, 18, 32 and 32. So that is what it is actually the merits of the modern is that first time atomic number is the basis, helps in predicting the properties, and the next is the, you can see, like you can have no problem for the isotopes, no problem for the argon and potassium anomalous position, I mean to say, and then blocks are classified, 4 blocks, all the elements are classified into sp and df block. So position, valence electron and the group number can well be explained by taking you can see, you remember how to justify the position of elements. If I take group 1, you can see lithium, sodium, potassium, rubidium, cesium and francium. 87, this is the 55, 37 and then 19, 11 and 3. It is the helium 2s1, it is the neon 3s1, it is the argon 4s1, it is the krypton 36 5s1, it is the xenon 54 6s1 and it is the radon. You know it very well during the discussion of the, you can see 7s1. Electronic configuration. So if I take any position, potassium, so to justify the position, inert gas, N to power x. N is the principal quantum number that gives the period. L is the azimuthal quantum number that gives the block, subset, SPDF. X is the valence electron that gives the group. So if I take potassium 19, it is the argon, so the configuration is 4s1. So tell me, N is the period, so period of potassium is the 4th. Which block of the element? It is the S block and group number is the 1. So if you take, you see cesium, to justify the position of the cesium in the periodic table, dear students, here you can see cesium, xenon 6s1. 6 represents the periods, S represents the block and 1 represents the group. Just like sodium 3s1, 3 is the period, S is the block and 1 is the group. In that way, modern periodic table is very useful, but no doubt it is also suffering from certain drawbacks. Like there is no proper position of lanthanide and actinoids. Next is the, you can see hydrogen की position still justified नहीं है, and the next is the, you can see helium is a S block but placed in P block along with inert gas. As the opinion was, it is still the stable gas. But no doubt it is the drawback. Then there is no proper group of the lanthanoids and the actinoids. In that way we have explained the periodic classification of element, Mendeleev merits and demerits, and the modern also merits and demerits, and the placement of the elements, and finally last but not the least is how to justify the position of elements in the periodic table by taking NL to power x. And representing the principal quantum number, L represents azimuthal quantum number that explains the block, and X represents the valence electron that represents the group. You just write down the atomic number, put the configuration and predict the position of the element in the periodic table. Thank you very much and have a nice day.